So in our previous class, we discussed 001, 002, where we talked about vectors, just to identify vectors and scalars, to know which one is vector, which one is scalar. If you watch that video, you'll be able to identify easily vectors and scalar. That is vectors and scalar quantity, scalars and vector quantity, 001, 002. Now, we're here, 003 of scalars and vector quantity. We want to look at the method. The method of adding or compounding vectors. We want to look at the method of adding or compounding vectors. What do we mean by that? There are two methods we use, which is triangular method, and then we have parallelogram. Let's divide the board into two. And let's pick the first one, which is the triangular method. Now, how do we solve vectors using triangular method? And if you look at the coordinate system, let's say that a force of 100 Newton travels towards the x-axis. A force of 100 Newton at an angle of 45 degrees travels towards the positive x-axis. Now, if you look at this illustration graphically, you'll find out that if you join this vector, we join to this vector here, so we have a triangle. We have something like this. We have something like this. And then we have this, and then this is the resultant vector. While this is the force of the x component, this is the force of the y component. Now, the angle is given to us to be 45 degrees. Whenever you have this illustration, the angle is given and the force, which is the resultant vector F, is given to be 100. How do you find those component forces? You apply the SOHCAHTOA. All right, let's start with the sine. Sine theta is equals to opposite over the hypotenuse. Sine theta is opposite over hypotenuse. If you are conversant with your trigonometry, you'll know that this is the opposite and this is the adjacent. All right, now this is the hypotenuse. All right, now sine is opposite over hypotenuse. So what we're going to have is that sine theta is equal to the opposite here is the f of y component. The hypotenuse there is f. All right, you can decide to put a 1 here and cross multiply. What you have is that Fy is equals to F sine theta. So with this formula, we can solve for the y component. So let's look for the cosine. So we have cos theta is equals to adjacent over hypotenuse. Now, we're going to know that cos theta is adjacent is the component fx component, that's the adjacent, over the hypotenuse, which is the f. Now you can multiply both sides by f, multiply both sides by f, so that f will cancel f. So fx is equals to f cos theta. So we will use this formula to get the fx component. Now, if you want to get the angle, assuming that the angle is not given to you, meanwhile, we're going to make that illustration later. Let's just move on. Now, how do you get this Fy component? So Fy component is equals to force sine theta. And the force we have there is 100 times cos 45, times sine 45. 100 times by sine 45. Let's use the calculator. So we have 100 times sine 45. That will give me 0.71. So I have 70.71 Newton. Sorry, not 0.71, 70.71 Newton. So my x component will become the F cos theta. Now, what's the F there? The F is 100. And what's the theta there? The theta is cos 45. Let's do that again. So I have 100 times cos 45. I'm going to have the same value, 70.71 Newton. Now, assuming that means that the Fx is 70.71 Newton, the Fy is 70.71 Newton. Now, assuming that the angle is not given, to get the angle, which is tan theta is equals to opposite over adjacent. So tan theta is opposite over adjacent. Let's make a space here. And if that is the case, tan theta is equals to, the opposite is f of y and the adjacent is f of x. Now take the tan inverse on both sides. When you take the tan inverse on both sides, tan inverse will cancel tan, so that theta will become tan inverse of f of y over f of x. So what we're going to do now, let's make a space for ourselves. Now, to find the theta, which is equals to the tan inverse of f of y is 70.71 divided by x component is 70.71. Let's do that in a calculator. You will eventually get 45 as the angle of inclination. Now shift tan 70.71 divide by 70.71. All right. So you see, we can have the angle to be theta to be 45 degrees, which is the same angle of inclination that was given to us. Now let's look at this illustration. Let's say that a triangle is given to us, or a body or a car moves 4 kilometers to the east and then 3 kilometers to the north. In this illustration, notice that this is a triangle. This is where the angle is A, B, C. So this is small letter C, this is capital letter C. These are the sides of the triangle. Opposite to B is small letter B over here, and here will be small letter A. Now, if you find the sides, the missing side of the triangle, we are going to use Pythagoras theory. And Pythagoras theory is C squared is equals to A squared plus B squared. So for us now, the C squared is equals to the 4 raised to the power of 2 plus 3 raised to the power of 2, and C squared, 4 raised to the power of 2 should be 16 plus 3 raised to the power of 2 should be 9. Then C squared is equals to 25. Transfer the square on this 25, so that C is equals to the squares of 25. And the squares of 25 should be equals to 5 kilometers. So the displacement of this guy, or the body that is traveling, is 5 kilometers. For instance, if the body is traveling on the coordinate system, it travels like this, 4 kilometers to the x-axis, and then like this, 3 kilometers to the north, or to the y-axis. You call this y-axis or the north, x-axis or the east. All right. So if you have that, the resultant vector will be somewhere around here, which is the displacement. And for this equation, or for this question, it is 5 kilometers. Now let's say the angle. We want to find the angle of inclination. So what we're going to do is that we're going to say tan inverse is equals to opposite over adjacent. So what you have, f of y over f of x. So the tan inverse is equals to, what's my f of y? is 3 over the 4. So what I have, tan inverse of 3 over 4. Okay? Shift tan of 3, which is the y, divide by 4. Alright, so over here I have 36.86. So let me make it 36.9. So over here is 36.9 degree. So my angle here will be 36.9 degree. That's the angle of inclination towards the x-axis or towards the north. Okay? Now, we move to the next thing. The next thing to do is to solve with parallelogram. And remember, you can also use this formula. F is equals to the squares of f of x squared plus f of y squared. You will get the same answer that the Pythagoras theory will also give you. Now, let's look at the parallelogram. Let's draw a parallelogram now. Let's say we have a force that starts from this position. A force starts from this position and then move towards the direction. Let's call this F1, which is 7 Newton. Another force moves towards the direction. Let's call this F2, which is 10 Newton. Now, before we start solving under parallelogram method of adding vector or compounding vector, we need to state the law of parallelogram. You see, to state the law of parallelogram, you don't need to cram those stuffs. Just know the shape of a parallelogram and I'll tell you how to state the law. Now, you have this parallelogram, meaning that there are two sides of equal value. So I have this side, okay, I'm not too artistic, over here, which become this side is equals to this side. All right, now this side will join up here, which means this side is equals to this side. So this is a parallelogram. You see, two parallel line, okay, parallelogram. All right, now if you have that, the resultant vector will come from here. Now let's take the law of parallelogram. The law of parallelogram states that when two vectors acting in magnitude and direction towards the adjacent side of a parallelogram, I take that again. When two vectors which is acting in magnitude and direction towards the adjacent side of the parallelogram, the diagonal, some textbook will call it, or the line drawn from the point of intersection, from the point of origin or the point of intersection, is the resultant vector in magnitude and direction. You can put it in a way, just understand the concept. When two vectors is traveling, two vectors, of course, in magnitude and direction, is traveling towards the adjacent side of a parallelogram, the resultant vector is the line drawn from the point of intersection. Are you following now? Or the diagonal from the point of intersection. Now, we know that if we bring down this guy who is traveling like this, okay, and we have the imaginary line of F1 traveling like this. So what we're going to have, this guy here will be the resultant vector. If you know, this is the A, this is the B, this is the C. So this becomes the small letter c, which is also equal to the resultant vector, and F2 is equal to B, and then F1 is equals to A. So what I have here will become, notice that we have an angle. Let's say we have an angle 60 degree. All right. Now, complementary angles or adjacent angles are complementary angle, which means that over here will be 180 degree. Adjacent angles are complementary angle. Now here will be the total angle, there will be 180. My angle, that is my degree, will now become 180 minus 60. And of course, 180 minus 60 is 120. The angle here is 120 degree. All right, so let's solve this problem. So what we have from the cosine rule, which is the rule of solving for parallelogram is equals to, let me clean up this now, is equals to c squared, which is equals to a squared plus b squared plus, minus 2ab. We don't need this one again now. We don't need it. 2 minus 2ab cos theta. So what's my a? Now let's find the a. The a is 7. 7 raised to the power of 2 c squared. And then b is 10 raised to the power of 2 minus 2, 7 times 10 cos 120. All right? So if you do that, c squared is equals to, this should be 49, and this should be 100, minus 2 times 7 times 10. And that should give me 1 something. So 2 times 7 times 10, 140, right? So this is 140. 140 cos 120 is what? So cos 120 minus 0.5. So cos 120 is minus 0.5. So what I have, if I add up this becomes 149, and then minus will cancel minus, and then I have 120 times 0.5, 140 times 0.5, 140 times 0.5. So what I have there is 70, so I have plus 70. Of course, when you add up these guys, you will now square it. So we have 149 plus 70, that will give me 219. So we have the squares of 219 will become my resultant vector. So let's square it immediately. Squares of 219, which is equals to 14.79. So let's round it up to be 14.8 Newton. So this is my resultant vector. My R here will be equals to 14.8 Newton. Of course, you can find the angle here using the sine rule, but that's not what we do today. We do it in another class. So if you want us to do it for you, or you're confusing it, just any question from all these things we have done, you can drop the question in the comment section, and then we will attend to you. Thank you very much for watching. Have a great day.